Hi everybody, just wanted to do a quick walkthrough of a couple more things today to give you a chance to maybe make some more progress. And in particular, I've made a little list of things that I want to cover quickly here. So I just want to remind you quickly about these environments in Julia and how to switch between them. In particular, how to switch back to the default one that comes with Julia installed. And then also because I realized on the GitHub repo and the video that I recorded along, obviously not all of the packages that you might need when you're playing around are included. In particular, there's sort of a couple that might be quite useful for you to have. One which is called Mat and another one called Plots. And I want to show you how to install them into the environment. And I will update this part on the GitHub repository. But if you don't know how to sync those changes, then you can just do that on your local install. And then I'll walk you through an example of loading in a mat file, which are actually produced by a program called MATLAB, which we use in my lab and in lots of other labs across universities. And one example of that is loading in an audio file, which is basically just a sample time series, right, of sound. And we want to plot those. And if we get time, we can also try plotting an image, which is something you might want to use to actually produce nice images for figures in lab reports and so on. Okay, so I'm going to switch over to my terminal window. I'm on a different computer at the moment, so the colors are a little bit different, but I've got Julia installed and Pluto and everything else. I'm in this directory which I've created, which you've downloaded as well. I'm just going to start Julia. Okay, so I've got a version 1.6.2, but hopefully it should work with any version just around about here. So if you look at the package manager here, which is the close square bracket, it shows you the current environment that we're working in. And in this case, this is the default package environment for this version of Julia. Okay. In the notes on the web page, I've told you that if you type activate dot, then it will use a couple of files if they're present in the folder to set up the current environment which you want to be working. So if we do that here, you can see that it made use of this file that I've produced for you. And you can also see that the prompt has now changed to this different bit of text. And we now have access to all the packages that I said we should include for this particular project. But I noticed that the packages mat and plots are not installed. So I want to add them to this current environment. And then hopefully this file project.toml and any other dependencies will be updated. And then that's a way to sort of add that incremental change to our project. Okay, so I'm going to add the package mat. You need to be connected to the internet for this to work. And you can see that it tries to figure out which other dependencies it needs. I think I actually downloaded this before, so they probably exist on my computer already. This might take a few seconds for you. So I've done this for this mat package. I also want to do it for plots. Okay. The first time I ran this, it actually took more than a minute, so it might take a little bit of time for you to do these things. Okay. Since I've added these things, actually, let me also add Pluto UI, which is something that you might have noticed that may have been missing in the original file, which just allows you to use the slider buttons and so on in the Julia in this Pluto notebook. So I'm going to try and use these mat and plot packages from the terminal window here, and then we can see whether this works in the notebook as well. But we can just write any code here as well. So if I'm typing using mat, it will try and prepare things and pre-compile the code so it can run nice and fast, and also using plots. So if you search around a little bit on the web pages for Julia, and discussion forums and so on, pre-compiling plots and making the first plot on your machine takes quite a long time, but once you've done the first one, every following one should be much quicker. So If this takes more than a few seconds, then I'm going to stop the recording and get back to this in a minute. All right, so it's finished. So I've now got this plots function, and just to illustrate what this is useful for, let me use Control L to clear the window. So we're at the top of the thing here. Let me make two variables, x and y, which are just going to be 100 points that specify 100 points that are going to be in an xy type plot. So I'm going to need 100 x values and 100 y values that go along with it, right? So one example could be if I make a range that goes from 0 to 1, and let's say I make this length 100. So that's going to be 100 steps, 100 points that lie between 0 and 1. And y, I'm just going to make a vector of random numbers that's exactly the same length, 100 points long. Right, so these are the numbers. And so the first thing I can try is just to plot x, y. Okay, so this means put the x values for each point along the x-axis and the y values on the y-axis. And this might take a second to issue this plot. All right, and you can see we've produced our first plot, which is very nice. So this is quite a useful thing to be doing no matter what you're going to do after this summer project. If you're going to do any kind of science or report writing or even working for a company, you're going to have to do a plot at some point. Maybe not this particular online plot of random numbers, but some other kind of data. You're going to have to plot it, okay? Another fun example, I guess, could be if I'm going to create a variable called y1, which is going to be all of the x values squared. Okay, so this dot caret means take each element of the vector x and square it and put that into this new vector y1, which hopefully sort of makes sense to you even if you stop doing maths at GCSE. And if I plot that one, so I just go up and I plot that one, go back here, you can see we get a nice curve, which you will all recognize as a parabola. Okay, one part of a parabola. All right, so that's really nice. So this tells you a little bit about adding packages and plotting. Now let's load in some data from a mat file to actually not just have to make up numbers, but actually load in an actual data file and see what happens with that. So for this, I need to use this package called mat. And just to remind you, in the data folder, so if I do ls data, there's a whole bunch of data files that I gave you along with this. And I think let's use the Beethoven 40 seconds, which contains some audio data. So it's a file that you could play on the computer. It's a digitized bit of Beethoven. And so I'm going to load that into a variable called data. And I'm going to use this command called mat open. And I'll just give it the file name, right? So it's Beethoven. Okay. So what comes back? Oh, mat read, actually, not mat open. Sorry. So the mat open command will open the file and allow you to grab bits of data at a time. The mat read command will try and slurp the whole data set into memory. And so it returns a slightly different kind of object in the programming language. It's called a dictionary, which if you've done any Python might sort of sound familiar. And it's basically a data structure that contains named variables that can be of different types. So there's a variable stored in this dictionary called y, there's one called t, which is a single number, some other details. And to access them in Julia, you can use this syntax, you use the square brackets, and then you give it inside strings the name of the field that you want to access. In this case, if we want to look at the y values, right, it returns a very, very long vector of numbers. And if we just want to take the first 100, then we can just do indexing, basically grab a selection of numbers from that vector that gets returned. So we can just add the indexing here, which is something hopefully you'll come across. Take the first 100 numbers, or go from 1,000 to 1,100. Okay, and see what that looks like. Actually, all zeros, right? So I wonder what's going on there. Oh, here's some numbers. Okay, so there's some silence at the beginning, obviously, where the numbers are all zeros, and then you go a little bit more. So I could store that subset in a variable called snippet, maybe. So on the left-hand side of this assignment, I give it the variable name. On the right-hand side is the bit that I want to actually evaluate, right? And I could plot that snippet. Okay, and you can see this is part of the sound wave that is a bit of Beethoven. Now, if you're interested in actually playing that bit of sound, that would be an interesting challenge. So you'd have to look around in the documentation for Julia how to play sounds from these kinds of waveforms, right? You'd have to look up how to actually do that on your computer using a package that we will have probably already installed as we went along. And this would be the first step to creating synthetic sounds on your computers if you want to make some music, which might be quite a sort of a fun random direction to take a little programming project here. The next thing I wanted to show you in terms of the plotting, right, just the last thing I'm going to do is to actually see whether we can use this plot command to actually show an image. Okay, and so for that I'm going to go back and remind myself what's in the data folder. And there's a bunch of images that are stored in JPEG format. So I could try and load those in using the commands which I showed in some previous videos as well. So let me try and do that. So if I use using images, okay, so there's a variable called data, which is gonna clash, but that's fine. If I hadn't named one of our variables data before, then we wouldn't have seen this warning message here. And I think there was a function called im. I just need to open it, right? So let me try that. So if I say im equals read jelly, it's in the data subfolder, so jelly. We'll read everything in as a long vector, but that's probably not what I want to do. Okay, so let me show you that there's no shame in Googling things and looking for help. So I'm going to go look for Julia images. Go maybe to the quick start. This just talks about what images are like. Hopefully there's something about loading images, so demos. These are not demo images, so let me go back here. It's all used for information. I read some of this a long time ago. Let's look back. Load images. Loading first image. Oh, we need file IO, and it's not read, it's load. Okay, so let's try that again. So I'm looking at this particular snippet here. So there's a package called file IO, which is So I'll type using file IO, and I'm going to go up a couple of times, and rather than using read, I'm going to use load. Okay, and so you can see that that actually loads the data in as an array, which is a table of numbers. That's 1024 by 768, which is, even if you're not sort of a computer type person, you might recognize as sort of a recognizable pixel count for images on computers. Okay, so let me just try and see what happens if I plot this image using this plot command. And actually, lo and behold, this plotting library is smart enough to understand this particular thing here. So that's kind of cool. So why is this useful, right? There's other ways of displaying images, but let's say, for example, you're doing a cognitive neuroscience experiment and you show people images of these kinds of objects, animals, different kinds of things, and you're interested in where their eyes are pointing. You may have some other data from an eye tracker, which is calibrated to show you where people were looking at when they were presented with this particular display. And this information might be stored in a different data set, and you want to plot the lines or the fixation points on top of this thing. You might want to have one layer of your figure be the image, and then a line plot on top of that. And that's actually something that we could play around with in a future little tutorial. All right, cool. So I hope this has been useful. Let me just add here, no shame in Googling solutions. Everyone does it all the time. And I guess the other thing is, which I demonstrated here in this little thing, is that even though I'd done something before a couple of times, because I've so in this case loading an image and in memory and trying to plot it out, sometimes we forget stuff, and that's also fine. Right. If you do things often enough, they will stick in your mind. If it's the first time you've done it, or if you've done something very similar in a different program, it's very easy to get confused. And the other thing is, don't be afraid of errors or making Julia say, there's a problem with this, because that's the only way you can actually learn stuff. So in this case, I was expecting this function to do the right thing, and then it turned out it wasn't really what I was expecting it to do. I didn't want a big long list of pixels for this image. I wanted this table, which I know is much closer to what I wanted to show. So, but I caught myself, right? And so I think this is a useful lesson here. All right. I hope that's been useful, and I will keep on adding a couple more exercises here. Use the Slack channel, right? And try and get some advice there as well. All right. Good night.